The secret U.S. plan to nuke the moon. The explosion that never happened. The year was 1958, and deep inside an Air Force briefing room, a handful of serious men debated something that sounds made up. Should America nuke the moon to boost national morale? It wasn't satire, it was real, funded, and stamped top secret. The operation already had a name that sounded harmless, Project A119, but the plan itself was anything but. Detonate a nuclear device so powerful it would flash across the night sky for everyone on Earth to see. Cosmic fireworks show meant to scream, "We're number one," into space. It stayed buried in government archives for 4 decades, sealed behind top secret stamps and destroyed reports. The question still baffles historians today. How did brilliant, rational men, physicists, astronomers, military officers, ever decide the moon needed to be nuked? To understand, you have to go back to a moment of fear and humiliation, when nothing mattered more than looking powerful, even on another world. Fear and Sputnik panic. In October 1957, a metallic sphere the size of a beach ball shattered America's self-image. The Soviet Union had launched Sputnik, the first artificial satellite, into orbit. It didn't carry weapons, only a tiny transmitter that beeped down at Earth every 96 minutes. But those beeps might as well have been warning sirens. To Americans, they sounded like proof that the US was falling behind, that the Soviets had suddenly mastered the technology to send missiles anywhere, even across oceans. Every rotation of that little silver sphere turned into a reminder that the Cold War wasn't just about ideology anymore. It was about altitude, technology, and fear. The reaction in Washington was instant panic. Newspapers screamed headlines about Soviet supremacy. Parents stared at the sky with binoculars, convinced the next launch could carry a bomb. Senators blamed the Eisenhower administration for letting America fall asleep at the controls. Military strategists began proposing the wildest ideas imaginable to win back technological prestige. To them, the moon wasn't just a distant rock, it was the perfect stage for psychological warfare. At that time, America's space program barely existed. There was no NASA yet, only military labs and scattered research projects. The Army, Navy, and Air Force all wanted control of space, and within that competition, a single phrase echoed in classified memos: visible proof of superiority. Scientists could launch small probes, sure, but those were slow symbols of progress. The military wanted something immediate, something spectacular, something the entire planet could see. A single explosion brighter than anything in the sky. A nuclear blast on the moon. It sounds insane now, but within the Cold War mindset, it almost made sense. The US had just been humiliated by a radio transmitter in orbit. The Soviets looked unstoppable, and in a war defined by perception, appearing strong was nearly as important as being strong. American generals feared that if the world thought the Soviet Union was more advanced, allies might lose faith and communist influence could spread unchecked. So the logic became twisted. If the Soviets wowed the world with a satellite, America would wow it with a sunrise of nuclear fire. Inside the Pentagon, proposals piled up. Some were practical: build better rockets, develop spy satellites. Others were unhinged: launch a nuclear missile at the moon, detonate it on impact, and show Earth who ruled space. The Air Force pitched it as both a propaganda coup and a scientific experiment. The real goal was theatrical: time the explosion on the moon's Terminator, the line between day and night, so half of Earth could watch the flash live. It wasn't data they wanted, it was applause. A global light show to make people forget Sputnik ever beeped. Power you could literally see from home. On paper, it seemed bold. In reality, it was desperation disguised as confidence. America's morale had plummeted after Sputnik. Schools started rewriting science curricula overnight, pushing math and physics to catch up with Soviet education. Politicians begged scientists for quick miracles, and for those in uniform, the message was simple: the public had to believe America still led the future. In that climate, almost no idea sounded too extreme. To the cold strategists, the moon symbolized the ultimate high ground. Whoever got there first would own an entire world. The Air Force's internal discussions described the moon as a psychological frontier, a billboard visible to every country below. A well-placed explosion, they argued, would announce that the United States could project power anywhere, even beyond Earth. The only problem was that nobody had actually sent anything close to the moon. Rocket reliability was dismal. About half of all test launches blew up or veered off course. A failed attempt could scatter radioactive debris across the atmosphere, but in the feverish late 50s mindset, hesitation was weakness. Risk was patriotic. The fear wasn't just technological, it was existential. If the Soviets dominated space, Americans feared they might dominate thought itself. Cultural confidence wavered. Talk show hosts played recordings of Sputniks beeping on air as if it were the sound of defeat. Schoolchildren practiced nuclear drills under their desks, while headlines speculated whether Moscow could soon drop bombs from orbit. Every beeping pass of that silver sphere reminded Americans of inferiority. So the response had to be colossal. Scramble to respond led to a kind of bureaucratic chaos. The Army wanted a manned flight plan. The Navy pushed for robotic explorers. The Air Force, driven by competition and prestige, went the nuclear route. Among high-ranking officers, the idea of turning the moon into a stage for America's technological theater was electrifying. And in typical bureaucratic style, no one stopped to ask whether it made sense. The conversation focused not on why, but how. What yield should the bomb have? Where exactly should it hit? How could it be seen best from Earth? That's the strange logic of Cold War paranoia. Fear made the impossible seem reasonable. The idea of nuking a celestial body wasn't about science, it was about reassurance. As long as America could light up the sky, nobody could doubt its dominance. The fact that it might destroy part of the moon's surface or fling radioactive dust into orbit barely entered the discussion. By the time 1958 arrived, the US wasn't just reacting to a satellite, it was reacting to humiliation. Fear had turned into spectacle, and spectacle into strategy. For the first time in history, military planners considered using a nuclear weapon not to kill, not to conquer, but to impress. The same weapon that haunted the planet since Hiroshima was now being rebranded as the ultimate public relations tool. That was the birth of the mindset that led directly to Project A119, where physics, politics, and ego collided in the most absurd moonshot ever conceived. The birth of Project A119. By early 1958, the panic had been distilled into instructions. The Air Force wanted proposals, visual, dramatic, and decisive. Within a matter of weeks, they drafted a deliberately bland title to disguise the nature of their goal, a study of lunar research flights. It sounded like dull paperwork about telescopes and rock samples. In reality, it was the most bizarre plan the Pentagon had ever authorized. The objective was simple on paper: detonate a nuclear device on the moon's surface. The purpose, however, was tangled in ego, fear, and bureaucracy. The name Project A119 would later become shorthand for Cold War absurdity, but back then it was a career-making opportunity. The military handed the project to the Armor Research Foundation in Chicago, a respected scientific institute tied closely to government contracts. That decision gave the plan an air of credibility. The head of the effort was physicist Leonard Riefel, a respected researcher who had previously worked with both the Air Force and NASA's early predecessor program. Riefel's job was to make sense of the impossible, find a way to set off a nuclear bomb on the moon and make it look good from Earth, as if physics were a branch of advertising. He wasn't alone. The Air Force assembled a small team of experts in astrophysics, nuclear engineering, and explosion dynamics. Among them was a 23-year-old graduate student named Carl Sagan. For a young scientist hungry to prove himself, joining such a secretive project was like being invited into the heart of the Cold War machine. Sagan, then studying at the University of Chicago, had already developed a reputation for mathematical brilliance and curiosity about planetary atmospheres. His task would eventually be to model the visibility of the explosion, the brightness of the resulting dust and gas cloud as it spread across the moon's silent horizon. He didn't yet understand the full absurdity of what he'd been enlisted for. None of them entirely did. They'd been told the project had both scientific and political significance. They just didn't realize how much of each. From the start, Riefel's team balanced between two explanations: research and public spectacle. In internal memos, the Air Force downplayed the propaganda aspect, emphasizing terms like scientific data collection and lunar surface analysis. But everyone knew what the real goal was: to create an unmistakable, headline-grabbing moment visible from Earth. The hypothetical schedule involved a small intercontinental ballistic missile carrying a lightweight nuclear warhead, perhaps a W-25 with a modest 1.7 kiloton yield, smaller than Hiroshima, but still capable of gouging a crater hundreds of meters wide. It would travel roughly 240,000 miles, impact on the visible side of the moon, and detonate precisely at the terminator so Earthbound observers could see the flash. Within seconds, the nuclear plume would send lunar dust into a vast, illuminated halo, hopefully bright enough for naked-eye observation. If successful, it would mark the first detonation ever conducted off-world. To outsiders, the concept might sound like bad science fiction. Inside the classified meeting rooms of 1958, it was treated as an engineering challenge. The project's guiding rationale was that there might be scientific benefits. By measuring the reflection of nuclear light on lunar dust, scientists could infer properties of the moon's surface. At least, that was the official scientific veneer. Riefel knew this justification was paper-thin. The data would be minimal and the risks astronomical. But the Air Force had approached the Foundation with urgency, and funding followed quickly. Nobody wanted to be the one to say the Emperor had no clothes. Sagan's mentor, Gerard Kuiper, one of the era's leading planetary scientists, also lent expertise. He added gravitas and theoretical insight, but remained skeptical. Kuiper privately questioned whether an explosion in a vacuum would even produce the effect the military wanted. Without atmosphere, there would be no dramatic mushroom cloud or roaring shockwave, just a brief, silent flash and a faintly glowing dust halo. The spectacle might disappoint spectators expecting cinematic drama. Yet Kuiper's name on the roster gave the program prestige. The Air Force could claim the country's best minds were tackling the problem. Behind the scenes, the reasons for secrecy were multiplying. Even mention of nuclear testing beyond Earth could have sparked international outrage. The Cold War's fragile balance depended on plausible restraint. Open talk of lunar bombing would annihilate that illusion. The project's files were stamped secret, stored in safes, and limited to a handful of personnel. Memos were shredded after reading. To anyone outside a tiny circle, the phrase lunar research flight meant harmless space experiments. That was the point. The label disguised the lunacy it contained. Within the Air Force, debates began about the appropriate size of the device. Some officers wanted something impressive, tens of kilotons, to ensure undeniable visibility. Scientists pushed back, arguing that too large an explosion risked unpredictable consequences. After all, no one had studied how radioactive particles might behave without an atmosphere. Would the debris remain trapped in lunar gravity? Could it drift into orbit? Might some of it even find its way toward Earth? No one knew, but such questions were quietly brushed aside. The bigger concern was reliability. Rockets in 1958 had a terrible success rate. If the unthinkable happened, if a launch detonated prematurely over Earth, the fallout could be catastrophic. But the Air Force wanted results, not hypotheticals. Doubt was unpatriotic, performance was mandatory. Riefel later recalled the internal tension of those months. On one hand, he was a scientist intrigued by the challenges of lunar measurement. On the other, he was horrified by the project's showmanship. He described feeling trapped between curiosity and conscience, working long nights to calculate something nobody should ever attempt. He and his team even drafted scenarios for aborting the mission mid-flight should the rocket begin to deviate from trajectory. But there was no real way to guarantee safety. Once launched, the warhead would either hit the moon or vanish in space. Failure wasn't an option, it was a probability. For Carl Sagan, it was an early immersion into the moral gray zone of scientific work tied to the military. His task, to predict dust cloud brightness, required assumptions that bordered on fantasy. Nobody had meaningful lunar surface data, nobody knew what regolith was made of. Sagan used theoretical models, plugging in estimates for dust density, sunlight reflection, and gravity escape velocity. The question he needed to answer was absurdly specific. Would an explosion this size, on that terrain, under that illumination, be visible from Chicago on a clear night? That was the intersection of patriotism and mathematics. Somewhere between those equations lay the fine line separating scientific inquiry from spectacle. As weeks turned to months, the armor team's reports accumulated in binders labeled with euphemistic titles: photometric analysis, visibility modeling, yield calibration. Each inch of paperwork edged the project closer to feasibility, at least on paper, yet unease grew. Some scientists confided to colleagues that the plan felt more like theater than research. The military supervisors, meanwhile, cared only about the timeline. A successful demonstration would need to coincide with a politically symbolic moment, perhaps around a national holiday or near the anniversary of the first Soviet satellite. The goal wasn't new information, it was applause. By the summer of 1958, Project A119 had taken shape, One small warhead, a medium-range launch vehicle, and a mission rationale that blended propaganda with pseudoscience. The team operating under Riefel could sense the momentum but not the wisdom of their task. They had resources, access, and security clearance, everything except a good reason. What kept them working was partly fear of questioning command and partly fascination with the impossible. Few projects had ever combined so much technical brilliance with so little sanity. From a distance, the moon looked unchanged, peacefully reflecting sunlight as it always had. But in a hidden Chicago laboratory, models of its cratered surface were plotted and replotted, each one representing a potential detonation point. That contrast, serene reality versus human folly, defined the spirit of Project A119 from the very beginning. What started as a panic-driven stunt turned into a surreal fusion of genius and lunacy. Scientists using the tools of reason to serve pure insecurity. By year's end, the documents described an almost cinematographic dream. A nuclear sunrise blooming above the moon, America reclaiming the sky not with exploration but with spectacle. Every graph, estimate, and equation brought the absurd vision closer to reality. What none of them realized yet was that another nation had been entertaining the same delusion across the ocean. The lunacy wasn't uniquely American, it was contagious. And soon, they'd find out just how far the madness had spread. The scientific justification. If you strip away the patriotic language and the classified stamps, Project A119 was basically a scientific costume for a publicity stunt. Early meetings in Chicago were filled with talk of data gathering, but everyone in the room knew the real goal wasn't knowledge, it was optics. Still, they had to cloak the mission in something that sounded legitimate, so they built an entire framework of science around a single, absurd premise: that detonating a nuclear device on the moon would somehow expand human understanding of space. It was the era's favorite trick: take a weapon, call it research, and hope nobody asks too many questions. The proposed benefits sounded respectable on paper. Scientists claimed the explosion could help study the moon's composition by analyzing the color and spread of illuminated dust. Some even suggested the burst might reveal traces of gas that could hint at geologic activity. The vacuum of space, they argued, offered a unique laboratory for physics. No air resistance, no weather, perfect conditions to study how energy dissipates in pure emptiness. Technically, all those arguments contained fragments of truth. But they were like ornaments on a collapsing tree, decorative reasoning stacked on rotting logic. Leonard Riefel later admitted that from the first week, he understood the science was wafer-thin. There were already safer ways to learn about the moon: spectroscopy, telescopic observation, later robotic probes. Blowing up part of it wouldn't tell you anything new that couldn't be learned by simply looking at reflected sunlight. But Riefel's team had marching orders, not debate privileges. He wrote careful memos describing secondary benefits, such as studying the dispersal of radioactive isotopes in lunar dust. In truth, none of them believed that would yield anything useful. It was intellectual camouflage for the military's theater. Optics mattered to the Air Force, both literal and political ones. That's why the scientists were told to run brightness studies first. Could a 1-kiloton detonation produce a visible flash under sunlight? Would dust reflect enough light to make the event spectacular? Carl Sagan's calculations dissected the question to death, but the underlying absurdity remained. These were physicists preparing a lunar show, not researchers uncovering secrets of creation. Meetings often drifted between technical charts and casual talk about how impressive the explosion might look to backyard stargazers. Somewhere between the slide rules and the cigarette smoke, the difference between science and spectacle started to blur. Cold War culture rewarded grandiosity. Every department wanted its own moonshot, sometimes literally. In an atmosphere of competition, bigger equated with smarter and visible equated with valuable. The scientists were trapped in that logic, the idea that any measurable event, no matter how ridiculous, could be justified as progress if it served national confidence. Sagan, still young and idealistic, probably believed he was contributing to legitimate research. Riefel, too seasoned to be naive, suspected the opposite. At meetings, he'd ask uncomfortable questions about fallout, safety margins, and orbital debris, only to see generals change the subject to public perception. There was almost comic contrast between the humility of scientific discovery and the arrogance of the mission brief. Rieffel's team spent months modeling trajectories and detonation yields with meticulous precision, while their sponsor simply wanted something Earth could see without telescopes. It was like hiring Da Vinci to design fireworks. The meetings stretched into the night, fueled by coffee and Cold War urgency. Each calculation nudged the idea closer to plausibility, but not reasonableness. This was science enlisted for a beauty pageant of nationalism. The technical discussions wandered into surreal corners. Could a blast on the shadowed side produce a longer-lasting plume? Would solar radiation interfere with the brightness curve? Should color film or infrared sensors be used for documentation? These were rational questions asked in service of an irrational mission. The scientists clung to method because method was their refuge. If they kept talking in equations, they didn't have to confront morality. It's easier to debate dust particle velocity than to admit you're planning an act of cosmic vandalism. One proposal even suggested simultaneous explosions at multiple points along the moon's rim to create a ring of fire visible to humanity, a kind of celestial crown meant to symbolize divine American superiority. The suggestion was dismissed as logistically impractical, not morally insane. That detail says everything about the mindset of the era. Madness had a budget as long as someone could fit it into a project schedule. There were quieter, more thoughtful voices amid the noise. Some younger scientists began to whisper concerns about future exploration. What if radioactive material from the blast contaminated potential landing zones? What if microscopic debris carried isotopes that interfered with later experiments? But those questions weren't written into minutes. In that world, ethical concerns were off script. The mission existed to prove capacity, not conscience. If the US could reach the moon first, even with a bomb, then America remained leader of the future. To keep the illusion of legitimate inquiry, Rieffel's group produced dense technical papers filled with formulas, tables, and phrases like expected particulate trajectory. But between the lines, you can sense their discomfort. They knew that under the neat graphs lurked a primitive impulse, fear disguised as ambition. The Air Force didn't need light curves, it needed reassurance. Each data sheet served as intellectual wallpaper covering the cracks of political insecurity. When Rieffel later described those months, he said the strangest part wasn't the idea itself, it was how normal it began to seem. After weeks of simulations, the team spoke about lunar detonation as casually as weather forecasting. Bureaucracy has a way of sanitizing madness. Once paperwork exists, the impossible feels procedural. A nuclear explosion becomes just another column in a spreadsheet. That's how human absurdity hides inside science. It dresses up in clarity until you forget what it's doing. And truthfully, it wasn't only the Americans flirting with lunacy. Rumors circulated that Soviet scientists were studying similar demonstration detonations. The possibility gave the US justification to continue. Mutual paranoia kept both sides inventing rationales for the irrational. The moon, once a symbol of poetic wonder, turned into a projection screen for ideological insecurity. The optimism of the 195s barely masked this anxiety. Publicly, officials spoke about humanity conquering space. Privately, they worried about falling behind. Project A119 embodied that contradiction, presented as curiosity powered by fear. Every chart about illumination duration carried the subtext, "Please let America look strong again." Rieffel's team wasn't chasing new knowledge. They were performing confidence theater with nuclear props. In hindsight, the entire justification reads like satire, scientists defending the ethics of lunar detonation because it might teach us about soil composition. It's the intellectual equivalent of burning down a library to study smoke patterns. Yet in 1958, the logic fit perfectly into the mindset of superpower rivalry. Knowledge had become inseparable from dominance. As the project advanced, so did the scientists' quiet discomfort. Some began drafting notes on potential environmental contamination, an odd phrase for a place without life, but it reflected something deeper, guilt. They understood they were about to scar an untouched world for ego. In later interviews, Rieffel said the growing sense of absurdity became impossible to ignore. It was not a good idea, he understated decades later, a gentle phrase carrying the weight of near disaster. For Sagan, those early months revealed the moral tightrope every scientist walks when curiosity meets authority. He entered Project A119, calculating how to make the moon glow brighter, and left with a lesson about how easily knowledge can be weaponized. Years later, his advocacy for nuclear disarmament and planetary preservation would trace its roots to this absurd episode. The young mathematician modeling lunar dust had glimpsed humanity's capacity for self-importance stretched to cosmic scale. By the end of 1958, the so-called scientific rationale had become a sandcastle of justifications, methodologically sound, ethically hollow. On paper, A119 looked plausible. In reality, it was ridiculous, a masterclass in how bright minds can rationalize dark ideas. The scientists had proved they could calculate anything except wisdom, and the moon, silent and unharmed, remained their unconsenting test subject. Carl Sagan's math problem. By the time Carl Sagan sat down to do the numbers, Project A119 had already crossed the border from improbable to absurd. He was 23, still a graduate student juggling coursework and a secret job that didn't officially exist. The assignment sounded simple enough: determine whether a nuclear explosion on the moon would be visible from Earth. In reality, it was a request so strange it bordered on science fiction. The Air Force wanted math that could make a mushroom cloud shine across 250,000 miles of vacuum. Sagan started with first principles: gravity, light, and dust. He imagined a small nuclear device, maybe the 1.7 kiloton W-25 warhead the team had chosen, detonating near the lunar terminator line. No air, no sound, no shockwave, just raw energy released into silence. The problem was nobody really knew what lunar soil was made of. Telescopes showed gray, uneven surfaces, but density, grain size, reflectivity, those were educated guesses. Sagan's calculations began to resemble an elaborate game of what if. What if the surface was powdery like volcanic ash? What if it was glassy and dark? Each assumption changed how bright the dust plume might appear. He scribbled formula after formula for particle velocity and escape angle, trying to predict how high the debris would rise in the moon's weaker gravity. Too little lift, and the light would fade instantly. Too much, and the particles would drift away, invisible. He treated the dust like a temporary atmosphere, capable of catching sunlight just long enough to flash toward Earth. His goal wasn't to measure destruction, it was to choreograph it. The Air Force wanted to know not how to destroy the moon, but how to make it sparkle efficiently. The calculations were tedious and speculative. Computers then filled whole rooms, so most work meant hours at a chalkboard punctuated by the smell of coffee and eraser dust. Sagan consulted his mentor Gerard Kuiper, who advised caution. The models were only as good as the guesses they rested on. Kuiper doubted a small warhead could make much of a show. Without air, an explosion would expand in a perfect sphere for milliseconds and then vanish. There would be light, he told Sagan, but not fireworks. Still, the young physicist pressed on, partly for the challenge, partly for the paycheck, and partly because refusing didn't feel like an option. Sagan built a theoretical brightness curve, estimating that the flash might rival a 6th magnitude star at best, faintly visible if conditions were perfect and you knew exactly where to look. To make the spectacle grand enough for television, the explosion might need to be 10 times larger, maybe more. That meant bigger payloads, riskier launches, heavier rockets, and a proportionally greater chance of disaster if anything went wrong on ascent. When Rieffel read the preliminary results, he reportedly muttered, "So we'd barely see the thing, and we'd risk irradiating half the atmosphere to try." Sagan just shrugged. The math said what it said. The absurdity deepened when the Air Force insisted on practical metrics. Could Sagan put a number on wow factor? They wanted a single value for brightness, something they could feed into public relations memos later. He joked to colleagues that he was computing the luminosity of lunacy, but he dutifully provided estimates. Under ideal geometry, the dust cloud might stay visible for a few seconds, glowing in reflected sunlight before fading into space. Under real conditions, moonlight would drown it out entirely. The phrase in his report was restrained, visibility uncertain for unaided terrestrial observers. Translation, probably nobody would see a thing. None of this changed the mission's momentum. The military clients read visibility uncertain as challenge, not warning. Maybe they needed a larger yield. Maybe they'd pick a darker crater. Maybe 2 warheads instead of 1. Sagan and the others kept recalculating. The equations grew thicker, the purpose thinner. Late nights blurred into mornings as he plotted dust column profiles by hand while imagining the absurd scene. Generals peering through telescopes, waiting to spot their victory flicker like a candle. These long sessions left an impression on Sagan. In later years, he rarely spoke about A119, bound by classification and conscience alike, but friends recalled he carried discomfort about it. He'd seen up close how perfect logic could serve complete insanity. The equations were flawless. The premise was not. The exercise proved that numbers could divorce themselves from meaning, that under bureaucratic pressure, even curiosity could become complicity. There were comic moments too, though rooted in unease. At one meeting, an officer asked whether the blast could carve a visible American flag into the lunar surface. Sagan reportedly froze, unsure if it was serious. Riefel diplomatically changed the subject to energy dispersion in impact ejecta. In another session, someone wondered whether the light from detonation might reach Earth in time for prime-time broadcasts. Sagan quietly calculated the answer, 28 seconds, and said nothing. Behind the humor, fatigue was setting in. Kuiper withdrew somewhat, leaving the younger man to finalize the mathematical portions of the monthly reports. Each document acquired a sterile authority, equations marching across pages like marching orders. Yet buried between them was the haunting line item that would come to define Sagan's involvement. Predicted magnitude of lunar detonation as observed from Earth. That single calculation turned the moon into a laboratory and a billboard in one breath. At some point, the young scientist began writing side notes, questions no one had asked him to answer. What percentage of ejecta would exceed lunar escape velocity? Could microfragments drift into cislunar orbit and eventually intersect Earth's path? He lacked data to solve them, but the possibility disturbed him. If even a fraction of radioactive debris escaped, it might orbit for centuries. The idea of future astronauts encountering glowing dust clouds wasn't theoretical. It was horrifying. Riefel later said Sagan's quiet doubts mirrored his own. They were building intellectual structure around moral emptiness, yet both kept working because stopping felt impossible in such a charged environment. Funding flowed, deadlines pressed, and secrecy rules forbade open debate. The irony was painful. A project designed to symbolize free world superiority was suffocating its own scientists under silence. Toward the end of 1958, Sagan completed the brightness study. His conclusion was unsatisfying to everyone. A small nuclear burst would produce little visual payoff and no genuine science. It was, quantitatively, a bad idea. The Air Force shelved that particular deliverable for re-evaluation, which usually meant filing it away until someone found a more convenient truth. Sagan handed over his notes, carefully avoiding any copy for himself, and returned to his graduate work. Years later, those documents would vanish entirely, either destroyed in routine purges or lost in classified archives. Only fragments of correspondence survived to hint at what he'd done. For decades afterward, that missing notebook shadowed his reputation. When biographers later uncovered references to Project A119, journalists asked whether the world's most famous advocate for peaceful space exploration had once designed a lunar bomb display. He never publicly confirmed it, though colleagues from the Armor team did. The irony wasn't lost on anyone. The man who would later write Cosmos once calculated how to make the moon glow from a nuclear blast. Yet within that contradiction lies the seed of transformation. Those months of secret arithmetic taught him the moral boundary between awe and arrogance. He saw that science could serve fear as easily as curiosity, and that intelligence offered no immunity against madness when patriotism demanded spectacle. The same mind that later spoke about pale blue dots first learned humility by glimpsing how close humanity came to vandalizing its nearest neighbor. When Project A119 quietly dissolved, most participants moved on, relieved to forget it. But Sagan carried its lesson into every lecture about stewardship of planets. He had seen human ego measured not in miles, but in megatons, and he knew how small our wisdom looked beside our power. In some ways, his entire later career, the outreach, the warnings about nuclear winter, the insistence on cosmic responsibility, was a lifelong correction to that one outrageous assignment in 1958. The math had been sound. The motive had been madness. The Soviet mirror, Project E4. While American scientists in Chicago were drafting ways to make the moon glow, Soviet engineers in Moscow were entertaining almost the same idea. They called it Project E4, a plan so similar to Project A119 that it reads like satire written in translation. Same era, same motive, to prove dominance through spectacle. The space race hadn't yet reached for astronauts or landers. At this point, it was still about fireworks. Both sides believed a well-timed explosion could win hearts, headlines, and history. In late 1958, Tucked within the USSR's top-secret missile program, nuclear physicist Yakov Borisovich Zeldovich gathered a proposal team inside the Institute of Applied Mathematics. Their brief sounded familiar: deliver a small warhead to the lunar surface, detonate on impact, create a flash visible from Earth. Unlike the Americans, the Soviets didn't even pretend science was the point. The goal was proof that the USSR not only could reach the moon, but could announce it with thunder. The state newspaper Pravda hadn't been shy about propaganda before, and an atomic sunrise on the moon would have rewritten every headline on Earth. Zeldovich's reasoning mirrored the paranoia haunting Washington. Soviet leadership worried that launching silent probes wasn't dramatic enough. Nobody would believe they'd actually reached the moon unless something visible happened. A crater you could see through a telescope, maybe even a lingering cloud, would turn disbelief into awe. Under Premier Khrushchev's direction, spectacle was policy. Show them what we can do. It wasn't research, it was theater draped in mathematics. Technically, Project E4 started as an engineering challenge. The designers at AK-1, the same bureau later responsible for Yuri Gagarin's flight, studied low-mass craft capable of carrying an atomic charge. The device would need initiator rods to guarantee detonation on impact, because remote triggering from Earth was impossible. Engineers debated yields between a few and dozens of kilotons. The smaller option was safer to launch, but too faint to impress. Just as in Chicago, science bowed to spectacle. The timeline ran parallel to A119. Both teams were calculating theoretical craters while nursing identical doubts. In Moscow, reliability posed the biggest obstacle. Soviet rockets still exploded regularly on the pad. If such a launch failed with a nuclear payload aboard, radioactive debris could rain back over Soviet territory, or worse, drift across oceans. For Zeldovich's mathematicians, those risk calculations were chilling. The chance of catastrophe hovered somewhere near certainty. Yet political zeal blurred the line between daring and suicidal. Within the corridors of the Kremlin, enthusiasm remained dazzlingly detached from physics. Propaganda chiefs imagined the explosion timed for a patriotic holiday, perhaps to commemorate the October Revolution. The flash, they said, would symbolize socialism illuminating the heavens. Meanwhile, sober scientists quietly drafted memos warning that an errant missile might instead symbolize international outrage. The internal split echoed that in the United States. Scientists whispering caution while generals demanded proof. One surviving account describes a planning session where an engineer pointed out that the detonation would produce no sound or lingering glow, only a brief pulse of light lasting milliseconds. "Could the people even see it?" he asked. "They will see what we tell them they saw," a superior replied. That single line summed up the philosophy of Cold War publicity. Belief mattered more than observation. If state television declared victory, the stars themselves could be persuaded to agree. Eventually, fear overtook bravado. The Soviet Union may have been willing to gamble lives on risky rockets, but gambling the planet's reputation on a potential nuclear accident felt different. The higher academia, men like Mstislav Keldysh and Sergei Korolev, urged restraint. Korolev, the legendary chief designer who would later launch Gagarin, despised the notion of polluting the moon. His argument was pragmatic and prophetic. If we reach it, we should stand upon it, not destroy it. With his influence rising, political winds shifted. By early 1959, Project E4 was shelved quietly, the components never leaving the ground. Still, the idea left residue. Classified reports on both sides show eerie symmetry, committees obsessed with visibility, equations for dust spread, speculation about human perception from 240,000 miles away. Scientists who'd never met were unknowingly solving the same nonsensical problem under opposite flags. It's almost poetic. Mutual paranoia leading to identical madness. The moon became a mirror not just in reflection, but in behavior. Each nation looked up and saw its own insecurities staring back. Behind this symmetry was a haunting truth about the age. The arms race had metastasized into psychology. Weapons no longer needed to detonate on Earth to serve their purpose. They just needed to remind the other side they existed. Whether that reminder came as a missile test, a propaganda film, or a theoretical lunar explosion didn't matter. Every gesture was theater meant to manipulate morale. A nuclear halo on the moon was simply the grandest stage imaginable. Project E4's cancellation didn't erase it from culture. Within Soviet laboratories, whispers persisted that the Americans were surely continuing their own version, which in turn justified keeping E4's blueprints ready if needed. Nothing fueled absurd projects like the belief that the enemy already had won. In the United States, the same paranoia kept A119 alive long past reason because commanders assumed the Soviets might strike first. Thus, two identical dead horses were kept standing out of mutual delusion. If you step back, the absurdity becomes breathtaking. Two rival superpowers, brimming with the world's greatest scientific minds, each spent precious resources designing nuclear fireworks for a barren rock that didn't belong to anyone. They justified it through math, cloaked it in secrecy, and nearly convinced themselves it was noble. The Cold War often turned logic upside down, but here it reached orbit. The moon, humanity's shared muse for centuries of poetry, almost became a billboard for egos armed with physics degrees. Historians later called Project E4 a symptom of collective hysteria. The phrase fits. Both nations were trapped in a feedback loop of fear, one that made irrational ideas appear strategic. In that sense, the Soviets canceling E4 first represented an unlikely moment of restraint. Their decision exposed how far off the edge the world had wandered, that sanity itself had become an act of defiance. When Leonard Riefel eventually learned, decades later, that Moscow had drafted almost the same plan, his reaction mixed relief and despair. Relief that neither side followed through, despair that the madness had been so symmetric it could pass for choreography. "We almost vandalized the moon in stereo," he said years after declassification. He wasn't exaggerating. Had logistics aligned, the two explosions might have occurred months apart, each claiming the same lunar glory. Instead, history was spared by a rare convergence of technical failure and human hesitation, but the episode etched a permanent mark on policy. After both programs collapsed, diplomats began drafting language that would eventually appear in the 1963 Partial Test Ban Treaty and the 1967 Outer Space Treaty, documents banning nuclear weapons in space and declaring celestial bodies the province of peace. In an ironic twist, two plans born of rivalry helped inspire cooperation. The same paranoia that conceived lunar detonations forced humanity to confront the need for restraint before anyone actually pulled a trigger. Project E4 faded into obscurity after that. Its files, like A119's, were destroyed or buried deep within archives. Yet its ghost still haunts every discussion about space militarization. Whenever debates arise over satellite-borne weapons or orbital defense systems, historians invoke E4 as the moment the world realized outer space could become the next battlefield. It stands as evidence that intelligence alone can't save civilizations from absurdity. Only humility can. So in the story of Nuking the Moon, the Soviets weren't villains facing heroes, they were reflections. Two halves of the same irrational era, both terrified of appearing weak, both ready to scar the sky to prove strength. If space exploration began as humanity's dream to reach the stars, Project E4 and its American twin remind us how easily that dream can curdle into spectacle. The Cold War didn't just militarize the planet, it almost weaponized wonder itself. The ethical meltdown. By late 1958, the numbers were in, the models complete, and the calculations, at least on paper, looked promising enough for detonation. But something else was happening inside the Armor Research Foundation's conference rooms. The laughter was thinner, the coffee breaks quieter. What had begun as a secret challenge to prove American dominance began to feel like a moral trap. Leonard Riefel sensed the shift first. He caught it in the half-sentences of his staff meetings. Small pauses before the word blast, uneasy glances when someone mentioned fallout. Their graphs and equations couldn't disguise what they were building, a bomb for the moon. Engineers whispered practical concerns cloaked as technicalities. Couldn't a misfire scatter radioactive debris into space? What if the launch vehicle lost guidance and exploded over Earth? The probability tables gave percentages, but the dread those numbers stirred wasn't statistical. They were imagining failure in human terms. A warhead tumbling through the atmosphere, breaking apart over populated land, turning the morale-boosting spectacle into catastrophe. Riefel wrote in one memo that unacceptable consequences must be considered, a bureaucratic phrase masking genuine fear. The Air Force's liaisons didn't want to hear it. In classified correspondence, they repeated the mantra of the age, controlled risk. They argued every innovation carried danger, the nation expected courage. To the scientists, it sounded like moral outsourcing. Someone else would take responsibility if things went wrong, but the blame would rest with the calculators. For Sagan and his colleagues, that tension became unbearable. Late at night, they'd keep the blinds drawn, discussing hypothetical failures in hushed tones as if the walls themselves had ears. The most alarming scenario involved premature detonation. A single miswired circuit or fuel leak could ignite a 1,500-ton fireball barely minutes after takeoff. The fallout could rain over continents. The probability wasn't remote. Half of all experimental launches still failed. Every new test explosion at Cape Canaveral felt like a silent countdown toward potential disaster. Rieffel urged his Air Force contacts to reconsider. Their answer came back blunt: proceed as planned until directed otherwise. The risk, they reminded him, existed purely in theory. That phrase offended the engineers. Theories were their trade. They understood better than anyone how real theory could become. One technician reportedly snapped, "So was Hiroshima until it was." That comment never reached official transcripts, but it circulated quietly through the lab, crystallizing the doubts no report could state aloud. Even the most pragmatic researcher began to sense the ethical absurdity. They were defending humanity by threatening a lifeless rock, as if morality only mattered up to low Earth orbit. The ethical reckoning deepened when discussions turned to contamination. Rieffel asked his team to estimate residual radiation on the lunar surface post-detonation. The numbers were small but not negligible. Radioactive particles might persist for decades, possibly centuries, embedding into regolith, an invisible fingerprint of human recklessness. Some argued the moon was barren, so contamination meant nothing. Others countered that its very barrenness gave it moral weight. It represented untouched creation, a celestial witness unscarred by history. To mar it with fallout felt like defacing an ancient monument simply because we could. Carl Sagan started writing personal notes about planetary protection, a phrase that would later define his activism. He wasn't drafting protest letters. He was working through guilt in equations. Could expelled isotopes reach escape velocity? Could solar radiation push them into Earth's path? His slideshows for internal review included a quiet footnote most officers overlooked: ethical implications significant. It was the only place the word ethical appeared in any A119 documentation. Meetings grew tense. The Air Force pressed for confirmation that visibility would outshine Soviet optics. The scientists kept circling back to risk. Rieffel tried diplomacy, reminding his sponsors that public reaction could be catastrophic if anyone learned America had detonated a nuke on the moon. Public support relies on admiration, not fear, he told them. A colonel replied, "Fear is just admiration with respect." That single line ended the discussion. Fear had become policy. Still, conscience slipped into the work through side channels. A few engineers confided to university colleagues under the guise of theoretical lunar energy dispersion. The colleagues, unaware of the classified context, responded with confusion. Why model destruction instead of exploration? Those offhand reactions stung. For the first time, the A119 team saw themselves from the outside. A group of brilliant people rationalizing vandalism. The moral fatigue followed them home. One researcher's wife later recalled her husband staring at the moon after dinner, muttering numbers to himself. When asked what he was calculating, he said, "How bright regret would be." She thought it was a joke until she learned what he'd been working on years later. The line became a kind of poetic shorthand within the team: how bright regret would be. Everyone understood what it meant. As doubts accumulated, Rieffel drafted an internal review recommending reevaluation in light of environmental, ethical, and public relations factors. That triple phrasing was deliberate code. Environmental meant potential lunar contamination. Ethical meant moral intolerability. Public relations meant panic. The document circulated briefly before being classified above his clearance level, effectively disappearing from the project's visible chain. In military logic, the easiest way to remove a problem was to bury the evidence. The Air Force doubled down. They began asking whether scientists could guarantee complete mission secrecy even after execution. They wanted reassurance that no telescope could detect the site precisely, that nobody could claim the moon had been struck. It revealed a quiet contradiction. The explosion was meant to be seen yet deniable. Such paradoxes thrive in bureaucracies where propaganda meets paranoia. Knowing that the plan relied on being both spectacular and secret only deepened the scientists' unease. By the winter of 1958 into 1959, moral collapse turned practical. Rieffel's best analysts began requesting reassignment. One left citing health reasons, but later confessed to friends that he couldn't stand solving ethics with yield equations. Carl Sagan started focusing more on his dissertation. Kuiper retreated to academic projects, reminding colleagues that astronomy was about understanding, not obliteration. The team thinned, morale evaporated. The Army's Jet Propulsion Laboratory, newly aligned with NASA, seemed a safer haven for ambition without corruption. The final straw came when Riefel pressed harder for an official ethics review. He wrote that detonation on a celestial body introduces irreversible precedent. Those words bothered people at the Pentagon, not for their meaning but for their permanence. Ethics tend to vanish in minutes, precedent lasts decades. Soon after, funding slowed. Communications from the Air Force arrived less frequently. What the scientists didn't yet realize was that political winds had shifted. President-elect Eisenhower was leaning toward a program emphasizing peaceful exploration. Quietly, enthusiasm for lunar bombing cooled. Inside the Foundation, relief replaced pride. "Maybe they've finally come to their senses," someone whispered, but the experience left scars. The months of doublethink had corroded their confidence in institutional reason. They'd watched morality bend under acronyms and memos, watched fear dress itself in scientific language until nobody could tell courage from compliance. The ethical meltdown of Project A119 wasn't a sudden protest. It was a slow thawing of denial. When interviewed decades later, Riefel summarized it simply. "We realized we'd crossed a line just by discussing it." Yet discussion was how he'd been ordered to serve his country. That contradiction defined the scientists' final weeks on the project, loyalty battling conscience until both were exhausted. By the spring of 1959, what remained of the team understood two truths simultaneously. The moon would remain untouched, and none of them would ever look at it the same way again. Politics versus science. By early 1959, Project A119 had reached a strange deadlock. It was technically feasible but morally radioactive. Inside the Air Force, that didn't matter. The chain of command still framed doubt as delay and delay as danger. The same week that Leonard Riefel's team started whispering about canceling the plan, a fresh directive arrived from Washington demanding summary of progress and anticipated demonstration potential. To bureaucrats, it looked like cautious optimism. To the scientists, it landed like a threat. The military wanted results, not reflections. At the Pentagon, the conversation had turned almost theatrical. Generals debated not whether the moon should be bombed, but how to spin it afterward. Some envisioned a press release about lunar seismic experimentation. Others suggested keeping it secret long enough to gauge Soviet reaction first. Within that maze, the scientists' voices grew faint. Carl Sagan's luminous dust curves and Kuiper's cautious memos competed with colonels discussing potential branding. One internal note proposed naming the event Lunar Illumination Test 1. Marketing masquerading as strategy. Riefel attended briefings in Washington where the divide between logic and politics became impossible to ignore. Across mahogany tables, uniformed officers described psychological advantage as if it were a measurable constant. They referred to visibility in terms of global morale vectors. Riefel realized the vocabulary itself had gone mad. Numbers meant trust, rhetoric meant victory. He had spent months measuring light intensity while his superiors measured applause. Meanwhile, NASA was forming out of the National Advisory Committee for Aeronautics, promising a peaceful path to the stars. The contrast embarrassed some officials. Here was one government branch selling exploration as hope, while another plotted lunar explosions under the same flag. Privately, some senators doubted the optics. If the world discovered the scheme, America's moral authority would evaporate. But within secure offices, the military pushed back. Restraint looked like fear. The argument condensed into a single grim equation. Diplomacy divided by paranoia equals stalemate. Scientists tried subtle rebellion. They drafted technical memoranda loaded with warnings disguised as variables. Uncertainty factors that ballooned into improbability, environmental variables hinting at contamination. But generals trained in procurement didn't speak the language of caution. They saw qualifications as excuses. One Air Force representative accused the armor team of scientific pessimism. Riefel nearly laughed. Scientific pessimism was the only thing saving reason. Carl Sagan withdrew into academia again, officially focusing on his dissertation but secretly writing notes titled Consequences of Off-World Detonation. He shared them only with Kuiper, whose response was curt. Politics wants symbolism, science wants understanding. We choose neither, they choose both. The line captured the exhaustion consuming everyone involved. Every time data contradicted strategy, new strategy rewrote reality. Then came the interagency tug of war. NASA's emergence gave civilians partial claim over lunar studies, creating friction. The Air Force considered transferring A119 under a sanitized title to maintain control. Civilian advisors objected, warning that any nuclear activity in space would violate soon-to-be-proposed test ban principles. For weeks, memos ping-ponged between departments, each side invoking patriotism to justify opposite outcome. The scientists waited, caught between organizations that measured prestige in decibels. Public relations planners even consulted psychologists to estimate reaction if the blast succeeded. Their conclusion was damning. The average citizen will interpret a lunar explosion as frightening rather than inspiring. That phrase, so obvious it bordered on parody, finally pierced the illusion. The same propaganda machine that had demanded a spectacle now feared it might terrify its audience. But rather than cancel outright, the Air Force doubled down on secrecy. "If we can't sell it," one memo read, "we don't tell it." Inside the Armor Foundation, morale hit bedrock. Researchers joked darkly that they were working on Project Schrödinger Moon, existing and not existing at once. Data collection continued out of inertia. Graphs mapped shockwave propagation that would never be witnessed. Exposure schedules plotted film timing that would never roll. The team's accomplishments became paradoxical. Every experiment brought them closer to proving what a bad idea it was. Still, higher command clung to ambition. One general argued that abandoning the project would embolden the Soviets, who might seize the idea themselves. Ironically, by that time the Soviets had already abandoned their mirrored plan, Project E4, deeming it too dangerous. But paranoia worked like gravity. It pulled reason inward until escape became impossible. The Americans assumed silence meant imminent threat. "If they're not talking about it," a colonel claimed, "that means they're doing it." Logic inverted into fear, fear into funding. Rieffel found himself writing two sets of documents, official updates projecting confidence and private notes recording despair. In the latter, he listed what he called ethical constants, principles that shouldn't fluctuate with politics. "The moon," he wrote, "is not a battlefield nor an advertisement. It is neutral ground for wonder." Those words never left his filing cabinet until decades later, but they reveal a man clinging to reason in a room built of pressure. The breaking point arrived during a classified symposium in early 1959. Representatives from multiple agencies gathered to review strategic alternatives in space demonstration. Rieffel presented cautiously, detailing risk factors and probability curves, emphasizing the near certainty of failure. Midway through, a senior officer interrupted. "If we don't strike first, they will own the heavens." The room fell silent. Rieffel looked around and realized no one was debating science anymore. They were confessing insecurity through equations. He ended his session with a quiet plea. "Gentlemen, the moon doesn't care who owns it." The transcript omitted that line. After the meeting, whispers spread that the project was losing momentum. Budget committees hesitated, unsure whether to funnel money into NASA's peaceful ventures or keep underwriting what one aide privately called a celestial stunt. Political winds were shifting toward prestige through exploration, not explosions. Yet inertia lingered. The Air Force refused to officially terminate A119. It simply stopped acknowledging it. That limbo satisfied everyone. A dead project nobody had to pronounce dead. The scientists, though, needed closure. Rieffel met with his remaining staff in Chicago and told them the probable outcome: silent cancellation, no announcement, no apology. They would archive their work under generic headings, return the classified material, and never speak of it again. The relief was mixed with bitterness. Months of sleepless nights had produced nothing but proof that sanity still existed somewhere. "We succeeded by failing," one physicist remarked. "That's the only success worth keeping classified." Outside, cultural momentum was already rewriting the narrative. Newspapers buzzed with talk of crewed landings and peaceful exploration. The same government that had flirted with lunar arson now promised one small step for man. But inside those promises lay erasures, the assumption that progress began with inspiration rather than guilt. The scientists who knew better kept quiet. Silence was the final clause of every clearance oath. For Carl Sagan, the experience etched a blueprint for his future approach to power and truth. He'd witnessed how fact could be domesticated by hierarchy, how reason could be drafted into marketing. Years later, he'd phrase it elegantly: "Science is a candle in the dark." But in 1959, that candle flickered in a sealed room, illuminating binders labeled A119. The final exchanges between the Air Force and the scientists bordered on absurd theater. Officials requested that all materials be returned for secure disposal. The Foundation clerks stamped received and shipped boxes to Washington, none realizing they were sealing away one of the strangest moral experiments of the century. No farewell ceremony, no final report, just signatures and silence. The project dissolved like vapor, leaving only strained memories and classified dust. Yet the tension between politics and science didn't vanish. It metastasized into policy. From that point forward, scientists entering government contracts carried an unspoken memory of A119. That curiosity can be twisted by insecurity. That progress without principle becomes parody. The Air Force had dreamed of turning the moon into a monument of power. They ended up creating a lesson in humility instead. In retrospect, the clash wasn't about technology. It was about the human flaw at the core of both politics and science, pride. One demanded applause, the other demanded understanding. Together, they nearly destroyed both. And as 1959 gave way to a new decade of space optimism, the people who once plotted the moon's destruction stood on their porches at night, looking up, grateful that bureaucracy, slow, tangled, obstinate bureaucracy, had finally saved them from themselves. The quiet cancellation. In the spring of 1959, Project A119 didn't end with fanfare or scandal. It simply faded out. There was no official cancellation memo, no decisive meeting where someone slammed a folder shut and said enough. It just withered through lack of appetite. Funding slowed, new space agencies took shape, and the room that once buzzed with feverish ambition went quiet. One by one, the scientists drifted away to safer, saner projects. In Washington, nobody wanted to attach their name to the report, concluding that the best way to advertise national pride wasn't to nuke the moon. The Air Force began redirecting resources toward cooperative ventures with NASA, which was now promising something far less sinister: human footprints instead of mushroom clouds. On paper, the Lunar Research Flights initiative rolled into other aerospace programs. In truth, it was quietly euthanized by changing priorities. The new vision of space was optimistic, human, heroic, a relentless contrast to the haunted secrecy that had surrounded A119. For the first time since Sputnik, policymakers realized that inspiration sold better than fear. Inside the Armor Research Foundation, Riefel called a final meeting. There was no announcement, just an air of relief laced with exhaustion. Stacks of classified binders sat on tables awaiting collection. Trajectory plots, radiation estimates, photometric charts, all destined for locked drawers or shredders. He thanked his small team for their discretion and professionalism, then added a simple sentence that none of them forgot. "We'll call it a successful failure." They'd proved something profound. That reason, left alone long enough, sometimes defeats madness by attrition. The official record soon became a ghost. A study of lunar research flights appeared on budget documents without explanation, quietly closing with the note study concluded. The project number A119 was replaced by new codes. Within months, no one outside a handful of clearances even recognized it. Yet the silence told its own story. The fact that it ended without a formal decision was precisely how the government liked its near catastrophes. Buried under paperwork, indistinguishable from routine. Riefel felt both triumph and shame. He later admitted that the cancellation was the only rational outcome, but it left behind a moral hangover. Each notebook and slide rule had been part of a machine that, if history had leaned slightly differently, might have scorched the moon for applause. For a brief breath in 1958, humanity's first step beyond Earth almost took the form of detonation. The absurdity wasn't just political, it was existential. They came within inches of redefining exploration as vandalism. Carl Sagan, meanwhile, moved on to finish his doctorate. Officially, he never mentioned the project again. The non-disclosure agreement, renewed annually, kept his lips sealed even as he built a career preaching the opposite of what A119 stood for. Yet the memory shadowed him. Decades later, when he lectured about the responsibility that comes with power, the deliberate care any species must take once it begins altering worlds, he spoke from experience he couldn't name. The moon had taught him humility the hard way. As for the physical evidence, most of it vanished. 9 progress reports, carefully typed and bound, were archived under security classification, secret. By 1987, they were destroyed in accordance with document control protocols. The only traces that survived were references buried in unrelated correspondence, a few lines acknowledging preliminary lunar visibility studies. Those fragments later became the breadcrumbs journalists followed when the story finally surfaced. But in 1959, no one outside the circle even knew there'd been a circle. Within the Air Force, a different narrative took hold, that the experiment had served its purpose as a feasibility test. It was never intended for execution, one summary claimed, rewriting history before the ink dried. Bureaucracies excel at post-event amnesia. Success was defined retroactively as restraint. The irony is that restraint wasn't planned, it just happened, the byproduct of competing agendas and reluctant scientists. Humanity's nearest celestial neighbor survived because indecision triumphed over determination. While files disappeared, the scientists carried quieter souvenirs, nightmares, doubts, long stares at the night sky. Riefel described looking at the moon afterward and thinking not of data but of relief that nothing up there bore humanity's signature. He returned to more conventional work in physics, but stayed wary of military contracts. Several of his former colleagues went into academia, where they taught about ethics in research, but could never reveal the story that had shaped their caution. Classified regret became a professional foundation. The Air Force never publicly admitted how close it came to executing the launch sequence. Internal test range schedules actually reserved tentative windows for high-velocity payload evaluation, a euphemism for the delivery vehicle that would have carried the nuclear device. When those dates passed without action, they vanished from planning calendars unacknowledged. Engineers at missile firms noticed the silence and drew their own conclusions. Some things were best left unexplained. By 196, the national conversation had shifted entirely. President Eisenhower promoted atoms for peace and peaceful conquest of space. The focus moved from impact craters to orbital trajectories, from destruction to discovery. Congress approved funding for Project Mercury, the first American program designed to send humans into orbit. In that climate, Project A119 looked like a relic from a darker timeline. The same officials who once demanded a lunar explosion now praised exploration as moral leadership. Nobody mentioned that the moral high ground had been a convenient substitute for radioactive fallout. Years later, when Leonard Riefel spoke publicly about A119 after declassification, his tone mixed bemusement with lingering disbelief. He described his younger self as a smart man doing a very dumb thing for serious people. He wasn't bitter, he was reflective. It was a product of its time, he said, when fear and pride made terrible ideas seem logical. His understatement carried the weight of suppressed alarm, an acknowledgement that luck, not enlightenment, had saved the moon from humanity's mood swings. For historians, the cancellation became a curiosity of bureaucratic entropy, an example of how vast systems sometimes correct themselves through confusion. No single hero canceled Project A119, it simply collided with more fashionable forms of ambition. If money had kept flowing, or if a different general had pushed harder, there might be a glassy crater today where telescopes now wander. The line between absurd theory and irreversible action often comes down to timing. From a distance, the end looked peaceful. No explosions, no scandals, just silence. But silence can be deafening when you realize what it covers. The moon remained untouched, glowing softly over cities where its would-be attackers slept off their exhaustion and went back to their ordinary lives. The explosion that never happened became invisible history, sealed in gray filing cabinets and forgotten until curiosity pried it back open 40 years later. In that sense, Project A119 achieved a strange immortality. It proved that restraint can masquerade as failure, and that sometimes the best success story is nothing happening at all. The world would remember the Cold War for brinkmanship, spies, and technological miracles. Very few would ever hear about the night humanity almost chose spectacle over sanity, and stepped back at the last minute, not from wisdom, but from weariness. The leak and public outrage. For 40 years, Project A119 existed only in whispers, buried under layers of bureaucracy so dense that even rumor couldn't escape. Then in the late 199s, silence cracked. It began quietly, with a footnote in Carl Sagan's early resume, unearthed by a biographer researching how the famous astronomer's career began. Listed between academic citations was a curious entry: radiation and dust modeling for lunar research flights. To most readers, it looked harmless. But to historian Leonard Riefel, who had led those research flights, it set off alarm bells. He was one of the only living people who knew what that phrase had really meant. Riefel realized that the secret was already halfway out, whether he liked it or not. The classified papers were destroyed, but his memory wasn't. When contacted for an interview in 1999, he decided to speak honestly. Yes, he admitted, we were asked to study whether detonating a nuclear device on the moon would serve any scientific or military purpose. The journalist on the phone reportedly went silent for several seconds. It sounded like parody, the United States seriously contemplating nuking the moon. Within hours, a draft of the article was circulating. By the spring of 200, the story hit global media. Headlines screamed with gleeful disbelief. The US planned to blow up the moon. Newspapers printed grainy photos of 195 scientists huddled over charts, as if caught plotting cosmic crime. Television anchors delivered the tale with nervous laughter, trying to confirm it wasn't satire. Late-night hosts turned it into material for jokes about government overreach. Beneath the humor, though, was unease. People wanted to know whether the most powerful nation on Earth had truly considered turning Earth's nightlight into a nuclear billboard. Public reaction split between astonishment and anger. Ordinary readers felt betrayed that their government, already notorious for Cold War brinkmanship, had once targeted the sky itself. Environmentalists called it lunatic fallout imperialism. Science educators were appalled that some of academia's brightest minds had played along. Internet forums buzzed with disbelief. Who thinks nuking the moon is a good idea? The timing made it sting even more. Humanity was preparing for renewed lunar exploration at the turn of the millennium, and now reminders surfaced that the same ambition had once meant annihilation. Historians scrambled to verify details. Most documents were gone. What remained came from interviews, leaked fragments, and cross-referenced memos in unrelated archives. Yet every check confirmed the same outline. Yes, it was real. No, it wasn't hypothetical fiction. Leonard Rieffel's credibility sealed it. As a respected physicist and former NASA associate administrator, he had nothing to gain from fabrication. His recollections filled in 60 pages of missing history. He even remembered the warhead type, the W-25, 1.7 kilotons, and Carl Sagan's quiet calculations about visibility from Earth. The revelation ignited a frenzy of commentary. Ethicists called it a case study in how fear can warp rational minds. Editorials mocked the logic of deterrence by fireworks. One columnist wrote, "It was as if the Cold War generals wanted to leave graffiti on the heavens." Even among veterans of the 195 space programs, the absurdity stung. Retired Air Force officers defended the intent, insisting it had been a serious scientific investigation during uncertain time. But each defense only reinforced the madness of the mindset. It showed how normal insanity had once felt. Carl Sagan, of course, was long gone. He had died in 1996, never publicly acknowledging the project beyond that cryptic resume entry. The press latched onto the irony. The world's greatest ambassador for peaceful cosmic awareness had started his career modeling a nuclear explosion on the moon. Commentators wrestled with that contradiction. Some accused him posthumously of complicity. Others saw it as youthful obedience in an era when saying no could end a career. His supporters pointed out that his later campaigns against nuclear weapons and his advocacy for planetary protection were born from lessons like A119. The ethical debate went beyond individuals to institutions. Questions poured into NASA, the Department of Defense, and the White House. Each issued the same terse statements. No such project exists today, and any similar concept would violate international treaties. Few recognized the irony. Those very treaties, like the 1967 Outer Space Treaty, had in part been drafted to prevent exactly the kind of situation A119 represented. The revelation reminded people how those laws weren't born from idealism, but from remorse. Social reaction blurred mockery with dread. Talk shows invited scientists to speculate what might have happened if the detonation had proceeded. Animations simulated a flash on the lunar surface, bright enough to momentarily outshine the stars. Some outlets treated it like entertainment, others treated it as evidence of Cold War pathology. Foreign newspapers ran gleeful headlines jabbing at American arrogance. Moon madness. US tried to play God. For a few weeks in 200, the story dominated science sections worldwide. A modern morality play about hubris delayed by luck. Then came the academic autopsies. University panel discussions dissected the psychology of 195's decision-making. Scholars framed A119 as a manifestation of technological sublime, a belief that any grand act, no matter how irrational, justified itself through scale. Students in ethics courses debated whether the scientists had a moral duty to refuse. Rare audio interviews surfaced of Leonard Riefel expressing regret. His voice, calm but weary, said, "We thought we were using science for security. Looking back, I see we were using science for spectacle." It became the quote most repeated in articles and documentaries afterward. The outrage cooled into fascination. Pop culture references appeared in novels, cartoons, and comedy sketches. The phrase Project A119 became shorthand for overkill, a cautionary joke about bureaucracy with too much funding. Yet amid the humor, real anger remained among the scientific community. Prominent astronomers wrote op-eds condemning the secrecy that allowed such a proposal to exist unchallenged. "Science," one wrote, "thrives in sunlight. A119 was a creature of shadow." The statement resonated far beyond academia, tapping into broader debates about government transparency and the lingering Cold War culture of classified science. Ironically, conspiracy theorists hijacked the revelation for their own fantasies. Online forums spun tales that the moon had already been struck, that shadows in Apollo photographs proved it. Real historians sighed, the truth was strange enough without fiction. But the myth-making only underscored how deeply A119 had entered the public imagination. The idea of nuking the moon was no longer just a forgotten scheme. It had become a parable about human excess. Leonard Riefel, then in his 70s, endured endless interviews. Reporters expected anger. He offered measured remorse instead. "It was wrong-headed," he said again and again. "The thinking of the time was dominated by fear. Rational people can believe irrational things when they're afraid." He defended Carl Sagan, calling him a brilliant kid caught in a system too big to question. Riefel's candor turned him into an unlikely moral witness, a man confessing on behalf of an entire generation of Cold War scientists. His honesty softened public judgment, transforming A119 from scandal to cautionary history. By the early 200s, as the shock faded, writers began exploring what the episode said about America itself. It revealed a culture once willing to entertain absurdities simply to feel secure. It showed how propaganda had infected even the pursuit of knowledge. And it explained why treaties banning nuclear weapons in space weren't just legal texts. They were acts of self-preservation for a species learning, haltingly, to restrain itself. Modern reflections tend to treat Project A119 less as villainy and more as symptom. It was proof that intelligence isn't the same as wisdom. Nations that could split atoms and reach orbit still measured success by flashbulbs and fear. When the truth finally escaped its vault, people laughed, but uneasily, sensing that the story's punchline was too close to home. Looking back, the outrage had a strange effect. It turned what might have been forgotten folly into shared memory, a reminder of how human ingenuity can tumble into absurdity when driven by panic. The moon had survived untouched, but the revelation scarred national pride more deeply than any crater could. By reading about what might have been, the public glimpsed the madness that secrecy once protected, and realized how thin the line can be between genius and lunacy when fear holds the pen. Legacy and lessons. When the dust of secrecy finally settled, Project A119 became more than a historical oddity. It turned into a mirror showing how arrogance dresses up as progress. The lesson came not from what the scientists achieved, but from what they didn't. The moon remained untouched, and that absence of action carried more meaning than any blast could have delivered. Over time, historians, ethicists, and former participants agreed on one truth. The near miss revealed the fragility of reason when fear writes policy. Project A119 didn't exist in isolation. It was part of a lineage of ideas born from panic, where intelligence bent itself into pretzels trying to look brave. The 195s treated innovation like an arms race with imagination itself, and A119 was its strangest offspring. Every spreadsheet, every experiment whispered the same insecurity. If we can't beat them with facts, maybe we can dazzle them with light. The irony is that the only illumination that lasted came from hindsight. In the decades that followed, the project's ghost reappeared whenever nations debated weapons in orbit or the militarization of space. Lawmakers cited A119 as Exhibit A for why legal boundaries were necessary beyond the atmosphere. The 1963 Partial Test Ban Treaty and the 1967 Outer Space Treaty didn't rise from moral transparency, but from accumulated embarrassment. Governments understood that without rules, panic could again masquerade as vision. Every clause banning explosions in space was a footnote to A119's madness, a reminder that humanity legislated restraint only after almost vandalizing the sky. Scientifically, the episode served as an ethics seminar disguised as physics homework. Universities used it to ask future researchers where curiosity should stop. Engineering faculties dissected the chain of command that let absurd ideas gain traction. The project became folklore among aerospace students. Remember, they once tried to nuke the moon. Check your variables and your conscience. It was both caution and comedy. The absurd story professors told to remind bright minds that brilliance without judgment becomes perilous quickly. Carl Sagan's personal legacy carried that theme quietly. The same man who calculated how bright a nuclear halo might shine ended up championing nuclear disarmament and planetary protection. His later crusade against the militarization of space echoed with personal experience he could never cite. When he warned about nuclear winter or spoke about Earth as a pale blue dot, he was atoning in plain view of the cosmos. The journey from secret mathematician to public moralist traced a straight line through the fallout of A119, an evolution from complicity to conscience. Leonard Riefel, too, reframed his life through that lens. After retirement, he lectured about scientific responsibility, urging young engineers to challenge illogic politely but firmly. His recollections carried neither melodrama nor denial, just weary gratitude that bureaucracy had delayed insanity long enough for reason to return. Sometimes, he told an interviewer, the system's inefficiency is the only safeguard we have. That paradox became the unofficial epitaph of the project. Saved by red tape, ethicists who studied A119 decades later found it eerily relevant. The psychological mechanisms that allowed smart people to rationalize an impossible plan hadn't disappeared. They'd merely migrated into new technologies, artificial intelligence, genetic manipulation, autonomous weapons. The doctrine of capability equals justification still hovered over science. In seminars, A119 served as an anchor. The moment humanity almost mistook theater for achievement. Each generation rediscovered it as a warning label, proof that intelligence isn't synonymous with wisdom. Politically, the fiasco offered the United States a chance at redemption it never publicly claimed. By switching narrative from provocation to exploration, the same institutions rebranded themselves as idealistic pioneers. The Apollo missions, though spectacular in their own right, quietly completed the rehabilitation. Instead of a crater lit by radiation, the world saw a footprint pressed into gray dust. That single human step erased the era's earlier impulse for destruction, transforming cosmic rivalry into shared wonder. Yet beneath the triumph lingered the memory of what almost replaced it. Historians often draw a straight line from A119's demise to the moral authority the U.S. needed during the space race. The cancellation proved that restraint could signal strength. The moon became a symbol of peaceful aspiration, not because humanity planned it that way, but because both superpowers nearly spoiled it first. The absence of explosion inadvertently gave the world a fresh definition of victory, mastery of self, not of weapons. Decades later, some fragments of irony returned in the digital age, when private companies and national programs debated mining and colonization. Commentators resurrected A119 as precedent, proof that even noble projects must guard against spectacle. The moon no longer faced nuclear annihilation, but the temptation to exploit it for prestige hadn't vanished. The lesson repeated. Technology amplifies motive, not morality. From a cultural perspective, the story seeded humility. The same newspapers that once mocked the revelation eventually embraced it as emblem of Cold War absurdity. Documentaries portrayed it half as dark comedy, half as morality tale. Teachers used it to spark curiosity in ethics discussions. How far would you go in the name of progress? The laughter it provoked was nervous, the kind that follows recognition. Everyone saw a bit of their own overconfidence reflected in those 195's planners. In leadership circles, A119 became shorthand for strategic folly. "Don't nuke the moon" entered bureaucratic slang to describe over-engineered solutions for non-problems. The phrase popped up in memos, management books, even political speeches. That longevity proved its power, a ludicrous event rescued from obscurity to remind professionals that objectives without reflection breed disaster. The moon itself became a silent monument to restraint. Every telescope image, every night of lunar glow now carries invisible subtext. This could have looked different. The surface might bear humanity's arrogance burned into glass. Instead, it remains only scarred by nature. That endurance turned the moon into a moral witness, a pale reminder hovering above every generation that forgets how close fear came to rewriting the night sky. Ultimately, Project A119's legacy rests on its failure. It exposed the junction where curiosity, ego, and politics collide, and how salvation sometimes comes from hesitation rather than heroism. The scientists involved proved that intellect can follow orders even when conscience wavers, but they also demonstrated that moral clarity eventually reasserts itself. Humanity learned, through near catastrophe, that not every frontier needs conquering by force. So when historians call A119 the explosion that never happened, they're describing more than a cancelled mission. They're naming a moment when sanity barely outweighed spectacle. The files may have turned to ash, but the warning endures. Fear and pride can launch any rocket, yet only reflection decides where it lands. The fact that the moon still gleams unscarred above us isn't an accident of engineering. It's the luckiest outcome in scientific history. A luminous monument to the wisdom of doing nothing. What we almost did to the moon. For a brief, unsteady moment in history, the fate of the moon balanced on a filing cabinet in Chicago. Fear had convinced brilliant minds to treat the sky as a stage and the atom as applause. The marvel isn't that Project A119 existed, it's that it stopped. Against a culture that worshipped spectacle, Restraint quietly won. Looking back, the absurdity almost feels mythic. Men of science debating how bright a nuclear dawn should appear while the world trembled below. Yet hidden in that madness was a fragile kind of hope, the capacity to reconsider, to pull back before the unthinkable became permanent. Humanity nearly vandalized its oldest companion and by accident learned humility instead. When you look at the moon tonight, it glows the way it always has, silent, patient, mercifully untouched. That pale light isn't just beautiful, it's proof that hesitation can be heroic, that sometimes the smartest choice in history is the one where nothing happens at all. We almost engraved fear into the heavens and instead left only reflection. If stories like this make you wonder what other impossible plans nearly changed the planet, you'll want to see what else history tried to hide. Subscribe, because the strangest chapters are often the ones that never happened, and they say the most about who we are when common sense finally shows up late, but just in time.